Hello, Algebra 2A students. This week we're going to continue with our endeavors with conditional probability. The problem set today deals with a single roll of 2 dice. And we're given 6 different probabilities that we're going to calculate. On the table of dice that I have, I've gone and I've crossed out the white because I can't have a white colored font on a piece of paper because it would not work. So just to know that on my table and on yours, the die on the left is the black one and the die on the right is the right one. And recall that the formula that we use is we want to calculate the probability of B occurring, and then our vertical line stands for the word given, that A has already occurred. All right, so B represents what could happen. A is what we already know has happened, so it's a clue in order for us to calculate our probability properly. All right, so starting with our first question here. It says, calculate the probability that the sum is even given that one of the dice is even. So the first thing I'm going to do is I need to calculate my denominator, and I need to find all of the outcomes where one of the 2 dice is even. Okay, and recall that if when you roll 2 dice, that you have 36 possible outcomes. All right, so go slow on these because this just says that one of the 2 dice is even, not both. Okay, so you don't want to use the ones that have both even ones. So this one, they're both odd. Here we got a good one, both odd. This one's a good one. This one's a good one. That one's good. This one's both, so we're not going to use that one. We're going to use this one, and we're going to use this one. One of them is even. Looks like that one's good, that one's good, that one's good, 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 and then good, good, and good. Now if I add all of these up, the ones that I have the check marks, that's going to be 18. That represents my denominator. Now, in order to get the numerator, I'm going to examine all the ones that I've checked and find out which one of these, how many of them have a sum that's even. All right, so that's a sum of 3, sum of 5, sum of 7. Those aren't any good. Sum of 3, sum of 5, sum of 7, sum of 5, sum of 7, sum of 9, a 5, a 7, another 9, a 7, a 9, and an 11. And then here we have a 7, a 9, and 11. So that's a 0. So the probability of this event occurring is 0. It's impossible. You cannot have, when you roll 2 dice and one of the 2 is even, you cannot add them up to get a sum that's even. All right, let's go on to example number 2. Example number 2 says, find the probability that the sum is 7 given that the sum is odd. So just like last problem, what I need to calculate first is I need to find the number of the 2 rolls that where the sum is odd. All right, so we've got 1 plus 1 is 2. This one would be a good one. This would be a sum that's 5. This would be a sum that's 7. And then we got a 3. I think you might start to see a pattern. Looks like all of the odd columns might have the 2nd, 4th, and 6th box circled. And then all the even ones, looks like you might have the 1st, 3rd, and the 5th. All right, so I've circled all of the ones that have a sum that is odd. We've got 6 plus 5, just to sample a few, 2 plus 5, 1 plus 6. and that is half of them, so that's 18. Now I'm going to go into the circled ones, and I'm going to locate all the ones that have a sum of 7. So I've got 1 here, 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. So that makes a grand total of 1, 2, 3, 4, 5, 6. That's 6 out of 18. And we like to reduce around here, so that's about a 1/3 chance, or about a 33% chance probability of that occurring. Next example. This one's a little bit different. This one just asks what's the probability that the sum is 9. Now note in this notation that we do not have a given line, and when that occurs, that means I'm not going to find a subset of them. I need to examine all 36, okay? So I need to calculate how many of these add up to 9 out of the 36 possible. And this is pretty easy to do. There's 1, there's 2, there's 3, there's 4. So it'd be 4 out of 36, and I'm going to reduce that to 1/9. Okay, fourth example. What's the probability that the sum is divisible by 3? And like question 3, this one does not have a given line, so that means I need to consider all the 36. So it's going to be some number out of the 36 possible. Now I just need to go and find all of the ones that have a sum that's divisible by 3. So first of all, we can figure 3 times 1, 3 times 2, 3 times 3, and 3 times 4. So I'm going to scan the table and find all of the sums that add up to these 4 numbers, and then that's going to be my numerator. So I've got 1, there's my 3's, there's another 3, so I've exhausted those. Now I got to get my 6's. Got all these. Now my 9's, did that last problem. And then our 12's, which we only have one 12, way down here. Now we just got to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 out of 36, also known as 1/3. Okay, so let's do one more example. We're going to calculate number 6 here. So what's the probability that the sum is odd given that the red die is even? So like all the previous ones, this one is a conditional question. We have our given line. So the first thing we want to find out is how many of the 36 have the red die and it's even. That's going to be our denominator. So scanning all the dies on the right, those are the even ones. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have another 18 total. Now in order to get the numerator, we need to examine all of the circled ones and find the ones that have a sum that is odd. Here's 1. We got 2 plus 1. 1 plus 4. 1 plus 6. It's 3. All of this, all of the even columns, if you examine real quick, is going to be an even plus an even, and that sum is always even. So we're not going to consider those. So we're going to go to the odd columns to get our solutions. And that would be 3 plus 3 plus 3, which is 9. So the probability is 1/2. Okay? Best of luck to you. Please ask questions. Thank you.